Hello guys, this is George Bunjat from Murray State University, and I am here to talk with you about an engineering measurement kit, very good Arduino Uno, very cost efficient, and about its possibilities, how can we use it in engineering measurements to accept analog inputs from sensors and to take these measurements into with the computer so we can analyze them later with Python, because this Arduino software doesn't have very good post-analysis processing techniques. In order to do this, first thing is to go and open a browser, and then you go and say Arduino download, and this will be very useful. So we can go there, and as you can see, we have Arduino download the IDE, and most of you, I assume, we're using Windows. If you use any other type of operating system, please do it. So follow it. So I'm gonna click on Windows, and of course if you want to contribute with donations, that's up to you. If not, go to just download, and this is the latest version of the software that I'm downloading. You can find in the future other version. Please download the latest one that you find, and please save it somewhere on your machine that you can find it. So if it goes in downloads automatically, you can do it. So, but I myself prefer to put them in my documents, and I have a folder that I call it kits, and in here, as you can see, I have others. Of course, under Arduino I have the latest one version, so I will not save it here. So, but please save it, and then then we go there, and then we run it. So after you save it, it will take a little bit, and then we can go and run it from that machine. Let me see where I am here right now. So in kits, I'll go there and say Arduino, and of course you can run it and execute it and go ahead. It's gonna follow, and in this case it tells me that's already installed, so I'll leave it as it is, but it's just follow the procedure. It will install it under program files, and you can find it there. So after you're installing it, then we just it will put here a icon for you in the desktop, and then you can open it up. That's exactly, and of course this is basically the last program that I myself have done. In your case, it will be something empty, so they will open up a file that's just having the void set up and the void loop put there. So in my case, I already wrote the code. The point is that this is the first code that we want to use in order to test that we communicate with the board. So in this situation, basically what we want to do is to just count. We use the board, the microcontroller on the board, so we can generate a signal and counting signal. Like every second, it will give us a number as a string, basically. So that's what we are doing. So in this case, I'm going to plug the board in before you run it. So that's already run the code. So you can see the ball, one tiny LED sending every second one signal. So that's exactly, you can type your code in there, and you will do the same way. So after you're done typing it, then in your machine, then we can run in this case. So it's going to compile, and it tells us that it compiled very well. And if I want to see what it does, I will click here, and I can see what it does. See, it's counting 1 Mississippi, 2 Mississippi, 3 Mississippi, and so on. So I have to stop it here a little bit and discuss what is going on in here. So of course we have to initialize, that's how it is in Arduino, we have to initialize a counter. In this case we started from 0. Arduino, like in C programming and Python, it always starts indexing from 0. So then we want to communicate with the board, so that's why we say here serial begin. It's a serial port. So anyway, this is the baud rate, how many bits per second it gives us. So in this case it gives us, it's a standard procedure to use 9600 bits per second as a baud rate for serial communication. And then we want to put this loop that you guys see here. So always it will print out I am counting, what it does, you know, and because as we were saying, this is in English, we say 1 Mississippi, 2 Mississippi, so that is 1 second it takes us to pronounce this. So every time the counter will index with 1, and it will, because this is much faster that we are doing, we have to slow it down a little bit, so 1000 milliseconds in order to do that. So this was done, so the board is running. If you get as I got, then that means it runs. If you do get, initially I got an error, so you can go here in tools, and of course the first one I had to select what Arduino board I have. So in my case I have an Arduino Uno, so I had to put that there. That was an error. The second error, you guys can see I have here selected COM6, which I didn't declare it in here because it's automatically doing in the software in the background. But initially it was not that, it was COM1, but that was wrong. So it was not finding the COM port, so because this was COM1 there, so you come here and you put COM6 like I did in there, and select the port. In other words, it was not selected COM6, it's just something, let me see how it was, it was some serial port, that's all it was, you know, so not selected the one. So in that case you will not have an error, and it will compile. And then we'll the next video I'll show you how to install Python and write the first code that we will not, basically, other than using code like this, there will be a one interfacing. We in Arduino will do the real and data acquisition with Python because it's giving us more flexibility, and also plotting procedures, not that only telling us what is equal. We can save the data after we're done acquiring and so on. I hope this was clear. If not, please send me an email at gbunget@marystate.edu. Thank you.